It began like any other interstellar encounter, a fast-moving object detected on a clear night, catalogued as 3I Atlas, and logged by observatories across the planet. But something about this one felt different. It wasn't just the speed, though at nearly 60 kilometers per second it was flying fast enough to escape the solar system forever. It wasn't just the size, its nucleus estimated between 3 and 7 miles wide, making it the largest interstellar object ever tracked. No, what set this apart was subtler. As scientists began plotting its trajectory, a crack formed in our certainty. The orbit didn't fit. It wasn't a matter of noise or data glitches. It was a measurable deviation, an orbital shift that couldn't be explained by gravity, solar radiation, or even violent jets of gas erupting from its surface. Something had changed its course, and the cause wasn't natural. That's when astronomers began whispering what they didn't want to believe. This is happening again. Just like Oumuamua before it, 3I Atlas is rewriting the laws we thought governed the universe. And this time, we can't look away. In orbital dynamics, every object plays by the same rules. Gravity dominates, gas outgassing complicates, but nothing moves in space without a traceable push. Yet when orbital modelers laid the path of 3I Atlas against reality, something snapped. The math fell short. The simulated trajectory, calculated with extreme precision using gravitational inputs, radiation pressure, and gas ejection estimates, no longer matched the observed data. Over time, the deviation grew, not wildly, but steadily. This wasn't a software error. It was confirmed by observatories across the globe. From Mount Aya to La Silla, every measurement aligned. But not with the model, with the anomaly. Residuals, those tiny gaps between predicted and actual positions, weren't random. They were systematic, always leaning in the same direction, creating a clear divergence that no gas jets could explain. Even when scientists added every known non-gravitational force to their simulations, they still couldn't account for it. The conclusion? Something invisible was pushing it, and it was doing so in a way that completely breaks the current playbook. When the James Webb Space Telescope locked onto 3I Atlas, astronomers hoped the object's coma would reveal the answers. Instead, it handed them a bigger mystery. Normally, a comet's tail is dominated by water vapor, with carbon dioxide playing a minor role. But 3I Atlas reversed that completely. The CO2 to water ratio was 8-to-1, a number so far outside the norm it stunned comet scientists. Worse, even this intense outgassing couldn't account for the force needed to shift a multi-billion-ton object. The gas jets were active, yes, but not active enough. Nickel emissions spiked sharply, but iron was mysteriously absent, an unprecedented asymmetry in interstellar chemistry. Meanwhile, the dust loss rate was relatively modest, powerful, but again not enough. The comet was erupting, yes, but not explosively, and so the same question kept coming back. What was pushing this giant off course? If sunlight, jets, and dust can't explain it, then something else must be at work, and that something doesn't look like nature as we know it. The feeling in the astronomy community was eerily familiar. In 2017, another visitor, Oumuamua, had shown a similar shift in trajectory. Back then, the object was small, tumbling, and completely dry with no visible gas jets. Yet it too accelerated slightly, just enough to throw off every model. Scientists bent over backwards to explain it. Maybe hydrogen outgassing, maybe radiation pressure, maybe even a fragment of alien technology. But no theory fully held up. And now, with 3I Atlas, the same pattern is repeating, but at a scale that leaves no room for doubt. This time the object is massive. If a force is pushing it, that force must be incredibly precise and sustained. And yet the models are breaking down again. It's no longer about one strange object slipping through the cracks. It's about a growing pattern, a sequence. First came Oumuamua, then Borisov, now 3I Atlas. And each time the behavior becomes more extreme, more unnatural. If this were a fluke, it wouldn't be escalating. But it is. And it's forcing scientists to ask a question no one wants to ask. What if this isn't a coincidence? Comet motion is simple in theory. Small bodies like icy rocks can be nudged easily by gas jets. But 3I Atlas isn't small. It's a cosmic juggernaut, possibly thousands of times more massive than Oumuamua. To shift something that heavy, you'd need explosive outbursts from its surface, ejecting tons of gas and dust every second. But that's not what the data shows. The measured gas output is high, but not that high. The force is simply too weak to move this mountain of rock and ice. It's like trying to push a cruise ship with a garden hose. So now the physics doesn't just look incomplete, it looks broken. And in science, when all conventional answers fail, the door opens to the unthinkable. Some whisper of fragmentation, others of exotic materials or unknown interactions with the sun's magnetic field. But behind closed doors, a few are asking, is it moving on purpose? Not in the science fiction sense of alien visitors, but as a technology, a relic, a probe, something designed to move subtly, to blend in, until we were smart enough to notice that it shouldn't be moving at all. As the residuals continued to mount, astrometric teams around the world began to shift their focus. The question was no longer, why is it drifting? But why is it drifting like this? The deviations weren't chaotic. They were patterned, consistent in direction, mathematically elegant. And for a body as massive as 3I Atlas, this level of controlled acceleration without detectable cause pushed the discussion into a space that scientists are rarely comfortable occupying: intentionality. What if the shift itself wasn't a symptom, but a signal? A quiet orbital nudge, not designed to escape observation, but to provoke it. As if the object were saying, here, pay attention, not by transmitting beacons or leaking radio waves, but by moving just enough to break our confidence. The orbit became the language, the drift, the sentence. It was subtle, yes, but in physics, subtlety is precision. And if the precision isn't ours, then whose is it? In the wake of this anomaly, scientific teams began doing what scientists do best, denying what doesn't fit. Peer-reviewed papers danced around the core issue, using euphemisms like non-conforming motion or unresolved trajectory deviation. Internal memos from NASA and ESA reflected growing discomfort. Some analysts began implementing residual isolation protocols to separate the unexplained shifts from the rest of the model, treating the anomaly not as part of the data, but as contamination. That alone spoke volumes. When the data is clean and the math fails, the error isn't in the measurements, it's in the model. And 3I Atlas was becoming an unignorable stress test for that model. This wasn't about fitting a strange rock into a familiar system anymore. It was about acknowledging that perhaps the system itself was incomplete. The last time this happened with Oumuamua, the world shrugged. This time the shrug is gone. What's replacing it is a growing silent dread. Just beyond the horizon of current observation lies the Vera C. Rubin Observatory, a game-changing facility preparing to sweep the sky with unprecedented speed and sensitivity. Its surveys will detect thousands, possibly millions, of small objects in the next decade, and among them, astronomers now realize, will be more interstellar visitors. But here's where the real fear sets in. If 3I Atlas is any indication, the truly strange ones won't look like sci-fi spacecraft. They'll look like rocks. They'll move almost predictably until they don't. They'll drift, gently, precisely, through our blind spots, right in front of our instruments, following orbits that are just plausible enough to dismiss. Unless you're watching every decimal. Rubin will give us eyes on the sky like never before. But if what we're seeing now is just the tip of the pattern, then the real revelation won't come from what Rubin finds. It will come from what Rubin proves we missed. Behind the orbital charts, the mass estimates, and the spectral readings lies a deeper fear, one not often spoken aloud. It's not that 3I Atlas is dangerous. It's not even that it might be artificial. It's that we might not be alone in the solar system anymore, and never were. Not in the way Hollywood imagined, with saucers and signals, but in the quietest way possible: observation. What if these objects, Oumuamua, Borisov, Atlas, aren't accidents, but checkpoints? Quiet instruments scattered across the galaxy, some inert, some dormant, some waiting. The evidence doesn't scream, it doesn't threaten, it simply misaligns, just enough to raise eyebrows and then questions and then possibilities. And that's the part that terrifies scientists the most. Not the answers we don't have, but the questions we're only now realizing we should be asking. Because if we're being watched, measured, evaluated, then 3I Atlas isn't the mystery. We are. As 3I Atlas moved toward conjunction with the Sun, radio silence followed. Not because we weren't listening, but because we couldn't. The object disappeared behind the Sun's blinding corona, placing it outside the reach of our most sensitive instruments. And it's in that silence, those gaps in observation, where something shifted. When it re-emerged days later, its orbit had changed again, subtly, precisely. Enough to be undeniable, but still without visible cause. This wasn't just an object being deflected by solar activity. It was behaving as if it had adjusted, like a correction made mid-course, like a probe responding to environmental parameters, and most disturbingly, like something that knew we'd be blind during the maneuver. The silence then begins to look less like a limitation and more like a window of opportunity. Not for us, but for it. Once 3I Atlas passed conjunction, its new trajectory no longer aimed toward interstellar space. Instead, analysts realized with growing unease, the object's path now put it on a course that would bring it close to Earth's orbital plane. Not a collision path, nothing catastrophic, but close enough to be significant. Its incoming trajectory had been steep and hyperbolic, a typical inbound vector. But after the second orbital shift, the outbound path looked adjusted, almost flattened, as if the object now intended to linger longer within the inner solar system. That's not what natural objects do. They pass by. They don't hang around. Unless, of course, Earth is no longer just another rock in space, but a destination, not for contact, not for invasion, but maybe for something much quieter, something observational, something that now treats our planet not as a random waypoint, but as a fixed reference. It's easy to forget how often we've been here before. Ancient cultures recorded signs in the sky, comets that didn't behave like the others, stars that flared and disappeared. Babylonian tablets, Mayan glyphs, even pre-Socratic fragments speak of stars that move against the tide, or gods with tails of smoke who visit only once. For centuries, those were treated as metaphor, myth. But now, in light of 3I Atlas, some researchers are beginning to revisit those accounts, not as superstition, but as observations, passed down across generations, describing something their authors did not understand, but faithfully recorded. The same directional tails, the same anomalous behavior, and now, the same orbital shift. Perhaps 3I Atlas is not the beginning of something new. Perhaps it's the return of something very old, and this time, we have the tools to finally decode what ancient eyes could only witness. When the data team at JPL modeled the current path of 3I Atlas post-conjunction, something unexpected emerged. A slow but clear inward drift, not just into the inner solar system, but toward a highly specific orbital insertion pattern. One that, if sustained, would stabilize the object within an extended elliptical orbit around the Sun. A kind of parking orbit. Not a flyby, not an escape, but a return path. Something built to come back, on a schedule. It's not just that the object's orbit has changed. It's that now, for the first time, it has one. A path that can be projected, tracked, anticipated. And what that orbit suggests is repetition. It will pass close again, and again, and again. A cosmic metronome set to a frequency we were never aware of, until now. And with every pass, the data sharpens. The patterns refine. The observation deepens. We used to think we were watching 3I Atlas, but what if from the very start, it was measuring us? When scientists analyzed the velocity vector of 3I Atlas post-conjunction, they noticed something subtle, almost imperceptible at first. The object was no longer accelerating randomly. It was stabilizing, not drifting, not tumbling. Its motion was becoming smoother, more coherent, more intentional. Normally, comets behave like chaotic debris, rotating erratically as jets of gas erupt from unpredictable points on their surface. But 3I Atlas began showing signs of rotational consistency, its axis stabilizing across multiple observations. The spin was precise, and with that, the question deepened. If this object was designed, if it had internal mass redistribution systems, or even a gyroscopic mechanism, then perhaps it wasn't just being pushed. Perhaps it was steering. And if it was steering, then the intelligence behind it wasn't just real. It was patient, because only something truly advanced would choose to speak not with language, but with motion so subtle it could be mistaken for nature. We often think of technology as noisy, metallic, undeniable. Rockets leave trails, signals leave static, machines leave signatures. But what if a truly advanced technology, one millions of years beyond us, does the opposite? What if it's quiet? What if its fingerprint is the absence of one? 3. I-Atlas has no radio transmission, no artificial thermal signature, no surface architecture that betrays engineering, and yet it behaves with the kind of refinement we cannot reproduce. It moves like a whisper through gravitational fields, exploiting them, adapting to them, adjusting ever so slightly at moments we cannot see. And every movement seems to say, we do not need to announce ourselves. You only need to be ready to notice. The fear, then, is not that we've been visited, but that we've been visited many times, and only now are we just barely intelligent enough to recognize that these aren't random rocks. They're navigators in the void, and we've mistaken them for dust. When the orbital data of 3I Atlas is plotted backward across time and compared with similar anomalies, Oumuamua, Borisov, even obscure transients from decades ago, a strange pattern emerges. Their trajectories avoid each other. Not like objects randomly flying through space, but like nodes in a distributed system, avoiding interference, optimizing coverage. As if they are part of a collective, spread across space and time, each one entering our system on a pre-assigned route, at a pre-assigned moment. It's a pattern no random process could maintain over such distances. And then it hits you. They're not exploring us. They're mapping us. Not physically, but cognitively. Tracking how quickly we detect the anomaly, how long it takes us to question it, how many of us react with science, and how many with fear. In this light, 3I Atlas isn't just a mystery. It's a mirror, held up to measure the maturity of a species standing at the edge of cosmic awareness. And the reflection we see may not be as flattering as we hoped. Perhaps the most haunting revelation of all came not from space telescopes, but from Earth-based sensors. Unexpected correlations between high-altitude ionospheric disturbances and the moments when 3I Atlas passed over Earth's orbital longitude. These weren't strong, they weren't obvious, but they were repeating, and they matched signatures seen only once before, when Oumuamua passed by in 2017. Similar magnetic flutter, similar residual anomalies in deep radar arrays. At the time, they were dismissed as solar interference. Now they look coordinated, not in a weaponized sense, but in a data collection framework. Like sensors were triggered, atmospheric layers were scanned, variables were logged, all without sound, without light, without trace, except for the one trace they left intentionally, the orbital drift. The only sign we were meant to notice. Everything else was passive, invisible. And that's the part that cuts deepest, because it means this isn't science fiction anymore. It's science we were too slow to notice, until now. When the data from 3I Atlas was compared with deep space scans taken months before its detection, something unexpected emerged. The object had been visible, barely, but no one noticed. It had passed through regions of the sky saturated with observations, including sectors under constant watch by sky mapping surveys. And yet, its signature remained buried, invisible not because it was faint, but because it was designed to blend in. The reflective index of its surface mimicked the background noise. Its thermal profile sat just above detectability. In every way, 3I Atlas seemed to know exactly how to move without being seen, until the moment it wanted to be. And that moment, as it turns out, coincided with a very specific window. A time when our instruments were just advanced enough to notice the shift, but not yet sophisticated enough to understand it fully. It's as if we're being trained, coaxed, to reach a threshold. And the silence isn't emptiness. It's a test, a space between signals where the question is not whether we're being observed, but whether we're ready to recognize the shape of the observation. In a final attempt to reframe the anomaly, independent astronomers began mapping all known interstellar visitors on a galactic coordinate grid, not by when they were detected, but by where they entered and exited the solar system. The result was terrifying in its elegance. The objects formed a constellation, not of stars, but of entry vectors, as if plotted along a greater web. The angles between them weren't random. They hinted at triangulation, survey coverage, and, most disturbingly, predictive spacing. This wasn't a scatter, it was a network. And 3I Atlas now looked less like a comet and more like a node, a piece of a vast observational lattice sweeping across planetary systems in perfect silence. The implication is staggering. We were never watching space. We were being charted by it. And if this mapping process has been active for thousands, millions of years, then maybe the question we should be asking isn't who are they, but rather, how long have they known we were here? We thought we were watching a rock, a drifting comet, another frozen relic from somewhere far away. But what we were really watching, what was unfolding before our very eyes, was the most deliberate silence we've ever encountered. 3I Atlas didn't scream across the sky. It didn't broadcast signals or send messages we could decode. It simply moved, wrongly, slightly, precisely, enough to make us pause, to make us question the one thing we never dared to doubt, that we are the only ones observing. But now, the orbit has changed. The motion is deliberate. The silence is structured. And the pattern, if you trace it far enough back, doesn't end with us. It begins with us. We weren't the destination. We were the variable, the final unknown in a long equation written by someone or something that has waited for this exact moment. The moment when we would notice the orbit had changed. So maybe this isn't about aliens. Maybe it's about timing. Maybe the universe isn't empty. Maybe it was just waiting for us to grow up, to look up, to measure what shouldn't move, and to finally ask the question we've avoided since we pointed our first telescopes to the sky. What if the watchers have always been watching us?